is 1, 1 times 6 is 6. Finally, you add everything together. 8 plus 0 is 8, 2 plus 4 is 6, 1 plus 6 is 7.
You can stop right there. So as you can see, it's very straightforward. There's not a lot of special stuff that you have to do, no visuals, drawing, or anything like that. It's just the problem itself. So we can go to the next slide. So this is a lesson example. I couldn't find a lesson plan for traditional math, but this is one that I did out of my Saxon Algebra 2 textbook. So if you've never used Saxon math, like I said, it's very straightforward. They just get right to the point. It's here's what it is, here's how to do it, and 11 different examples of how to do it. And after that, you go into your lesson practice, which just focuses on the content that you learned in the lesson, and then you move on to your review practice, which encompasses everything that you've learned up to that point. So, next slide, please. So some pros and cons of traditional math. Pros would be there's lots of time to review, practice, lots of repetition. For me, that was really helpful because if I'm not constantly using what I've learned in the past, I'm going to forget it even just within a couple of days. It does build on itself, so with Saxon, everything kind of flowed in a very linear fashion. There wasn't just like jumping from fractions to geometry or anything like that. It's very thorough, straightforward, and easy to use. I was homeschooled, as most of y'all know, so I did my math in co-ops, and most of the people who were teaching the lessons in those co-ops did not have a teaching degree, but they were able to take the textbook and the lessons and just go with it. There wasn't a lot of prep that they had to do for it. You can use manipulatives with it, so there is some hands-on adaptations that can be made. And it does promote automaticity through all of the repetition. Cons, it's expensive. My mom spent a lot on Saxon. There's little eye appeal, so like I said, not really a lot of visuals to use. It's just the formulas. Not particularly creative. There's lots of explanations, and because of that, it can be very time-consuming. Again, repetition, so if you are really familiar with a concept and you've got it down pat, because there's so much repetition, you can get bored, and as a teacher, you lose your students really easily. And then it fails to promote conceptual understanding.
And so I'm going to talk about the Chicago/Everyday Math. Everyday Mathematics, or Chicago Math, is a K-6 curriculum developed by the University of Chicago School of Mathematics. They claim it's based on over a century of how children learn, but I feel like they said that just to make it sound fancier than it is. One thing I really do like about it is it presents multiple methods or procedures for basic operations of arithmetic. So like say you have the number 10, how many options do we have to get to the number 10? Well, for addition we have 5 plus 5, 6 plus 4, 7 plus 3, 8 plus 2, and 9 plus 1. And that's only addition. For multiplication, there's 10 times 1 and 5 times 2. That's 7 different ways to get to 10, but they're all equal to 10. Or like that, what's that one saying? There's more than one way to skin a dead cat. I think that's what it is. One thing based on it, what it looks like, it takes on a more realist or experimentalist approach to teaching, with them showing you different ways to do different things other than traditional. That's why I would put it in experimentalist. Repetition, or as they call it, spiraling, is really key in this because you're constantly building on stuff. So one procedure you learn early on in the curriculum, it'll come back again, and then you'll just add on to it. This video right here, he's going to talk about some of the graphical data to show here's why this program is successful. We've been doing multiple studies around each state's test scores and stuff. Could you go to 6 minutes and 8 seconds, I believe?
Absolutely. 6, 8?
I believe so. Yeah.
Country who use everyday math across a few units. We can see the higher level of achievement of students all over the country who use everyday mathematics. For example, in the state of California, on the 2013 California Standards Test in Mathematics, the percentage of students scoring at proficient or advanced declined pretty sharply after grade 4. But in Conejo Valley, longtime users of everyday mathematics, the scores, which already outpaced the state in every grade, stay high, even in the upper grades. We can also go look at students who go on from elementary school to take an algebra course. In the state of New Jersey in 2013, just under 30% of all students in the state took an algebra course. And of those students, only 60% scored a grade of C or better. But let's look at Elizabeth City, New Jersey. That's an ethnically diverse district, and they're also longtime users of everyday mathematics. In Elizabeth City, almost 100% of students went on to take an algebra course in high school, and of those, 75% received a grade of C or better. And the impact of everyday mathematics can be seen in the first year the program is implemented. On the 2010 Tennessee Comprehensive Assessment Program, in the Murfreesboro School District, under 50% of students in grade 3 scored proficient or advanced. But when they implemented everyday mathematics in the 2011 school year, that score jumped 15 points to 63% proficient or advanced. And that number's grown to 70% proficient or advanced last year. That's a 20% gain just 3 years after implementing everyday mathematics. And those results have been verified by the U.S. Department of Education's What Works Clearinghouse, which has found that using everyday mathematics, your students could see gains double that of other programs. So I'd like to thank you for this quick.
So based on that data, he's pretty much arguing that this is a really, really effective curriculum. One thing to keep in mind though, there's 50 states in the country. There's a lot of schools in those states, so all of their students learn differently. So what may work for one school may not work for another, so that's just one thing to keep in mind. I'm going to go through the latest method of multiplication. Now, right now, it's in standard form. Most people will do long multiplication. That's due to it having 2-digit numbers. If it was like 21 times just 7, then that'd be regular division. But since it's 2, we go to long division. Now, is anyone familiar with the latest?
Lattice.
Lattice? I've been saying it wrong.
That's okay.
But I'm going to go ahead, I'm going to actually write it down on the whiteboard because I found if you just show a completed formula, it could look kind of goofy. So over here, so for 21 times 17, how to set this up is you're going to make a box, just like that. And then you're going to draw a line straight down the middle and then right across. Now the reason why it's only a 2x2 square is because it's your multiplicand is I already said it is 2 digits, and then your multiplier is also 2 digits. So the first number, 21, is going to determine how long it's going to be, and then the second number, which is 17, is going to determine how tall it is. So it's just a standard 2x2 square. And then one thing you're going to do after this box is done is you're going to draw straight lines just like this. And this will come into play at the end of the equation. So now you're just going to go do standard multiplication. 1 times 1 is 1, but the problem is 1 times 1 is 1. That's only a single digit number. So what do we do? There's 2 boxes. You're going to put a 0 right there. You're going to treat it as a 2-digit number. So that 0 kind of counts as the tens place. Do the same thing. 1 times 7, again that's 7. Treat it as a 2-digit number. So we get 0 and 7. Now moving on, we're going to go to 2 times 1. That's 2. 2-digit number, 0 and 2. 2 times 7, 14. And then, so you got 14 in that box. Now, the reason why at the beginning when you draw these lines right here is so that you're going to add each of these rows together. So 7 is by itself, 7. 4 plus 0 plus 1 is 5. And then 1 plus 2 plus 0 is 3. And then 0 is all by itself. So now, this is the answer to our equation. It kind of looks like a neat little path right here. So right now, our answer is 357 is what equals when you multiply 21 times 17. For the next one, for 96 times 94, set it up the same way. Standard 2x2 box, 96 on top. 94 on the side. They're kind of straight. All right, 6 times 9, 54. 6 times 4 is going to be 24. 9 times 9 is 81. 9 times 4 is going to be 36. And so now, just do standard addition. 4 by itself is 4. 6 plus 2 plus 4 is 12. So you're going to put the 2 right there. Now you have 1 as a remainder. So you're going to take that 1, put it all the way up here. So now when you add this row together, you do 3 plus 1 plus 5, which is going to be equal to 9. And then your remainder carry over the 1, you're going to get a 10. Same principle, take out the 1, put it up here. 8 plus 1 is equal to 9. So our answer for this one is going to be 9,024. And for the last one, you can see it's a 3-digit number on top and then a 2-digit number on the bottom. So that's going to change the way your box is set up. So you're going to go it'll probably be a little bit longer, but you're going to draw 2 lines straight down the middle. Well, not straight down the middle. And then 1 line across because it is, you got 3 digits and then a 2-digit on the bottom. So it's just a 3x2 format instead of 2x2. You're going to put your top one on. It's 312. And then 64 there. And then you're going to draw straight lines through all the boxes. And now you just do pretty much the same exact principle if you're doing 2x2. So 2 times 6 is equal to 12. 2 times 4 is equal to 8. Treat it as a 2-digit number. Then move on. 1 times 6 is 6. 1 times 4 is 4. And then for the final one, 3 times 6 is 18. 3 times 4 is 12. And you pretty much do the same addition. So 8, 6, 9, 9, and then 1, which comes out to 19,968. This probably won't be your standard way of doing multiplication. One thing I really like about it is it gives you just another way to double check your work. Because